Good morning, students. So in our last class we complete 3 questions, is not it, from application of derivatives. So now here the next question is question number 4. If you see, the question number 4 is given here and the question is given, find the interval in which the function f given by fx equal to 2x square minus 3x is what we need to prove, strictly increasing and strictly decreasing. Here actually we have to find out, not prove here, we have to find out the interval, is not it. So interval we have to find out for strictly increasing and for strictly decreasing, and the function is given fx equal to 2x square minus 3x. Is it clear? So now this one is the question, and let's see how can we find out. So before find out the interval here, if we recall how to find out this, so there one method we know, wavy curve method. There are lots of methods are there to find out the interval, is not it? And in this case when we find out the interval here, wavy curve method is there, and especially the wavy curve method is applicable for algebraic expression, is not it? So now another 2 methods are we discussed here. So now here if you see the function is given fx equal to 2x square minus 3x, that means it is an algebraic function, so easily we can apply here the wavy curve method. So that's why we have to use this wavy curve method and find out the interval. So before this, what you have to do, let's see the process, the procedure, what you have to do here. So for this, first of all, what you have to do, fx. So now in this case, if we see the given function, so the given function is given fx. So fx equal to given here 2x square minus thrice x. If you see the function is given fx equal to 2x square minus thrice x, is not it? So now what you have to do, first step we have to differentiate this one with respect to x. So the first step is here, always we have to do this one. So f dash of x, so f dash of x, if you differentiate this one, you see 2 is constant term, come outside. So ddx of x square, so ddx of x square means twice x, 2 to 4, so that means we write here 4x minus here 3x, 3 is constant term, so come outside, ddx of x 1, so that's why here simply remain 3. So f dash of x equal to this one we get. Is it clear? So now to find out the interval, what you have to write now, f dash of x. So each and every time we have to write this one, it is fixed, f dash of x equal to 0, each and every time we have to write. Is it clear? So now here after differentiation, each and every time we have to write f dash of x equal to 0 to find out the critical points or stationary points. That means the value of x we have to find out here. So now in this case, if you see here f dash of x, so f dash of x value already we know. This one is how much? 4x minus 3. So that's what we have to write. This one we have to write here, 4x minus of 3 equals to 0. And now from here, if you find out the value of x from here, what we get? We get 3 by 4. Is not it? So this x is known as critical point or stationary point, or simply here x equal to how much we get here, 3 by 4. So now after getting this one, now with the help of wavy curve method, easily we can find out the here interval here. Let's see how can we do this one. So if you see the graph here now, after this, if you see the graph here, so graph, in this case what you have to do, we have to draw a number line, and the number line is from minus infinity to plus infinity. So we have to draw a number line from minus infinity to plus infinity, and then under this number line we have to plot each and every point. So here x, how many values are we get? Only one value, so that's why we have to put this point here. So if we put this one, x equal to how much here? X equals to 3 by 4. This one we have to put. Is it clear? So x value is 3 by 4, simply we have to put here. And then after that, the wavy curve method, what you have to do, whatever the point we get from the right hand side, from the above part, we have to start the graph. Is it clear? From where we have to start? So the point, whatever we get the end point from the right hand side, and from the above part we have to start. That means point to jodi yaar ase, point to jodi yaar ase, ami yaar par graph to start korim. Is it clear? So if we start a graph from here, the graph moves like in this direction and goes any other point if we get, then again it moves, but there is no other point, so that's why we have to keep like in this way. Is it clear? This one is the graph here. Simply one point is here, so that's why we get the graph like in this way. Is it clear? So now in this case, what we get here, this portion is for increasing, strictly increasing or increasing, and this portion is for decreasing. Is it clear? This portion is for decreasing. I think all of you understood this one now. So now in this case we get the condition either f dash of x greater than 0, or another condition we get here, what? F dash of x greater than equals to 0. Is it clear? Either we get this one or this one. Any one of this one we get. This one is totally depending on the question. Similarly, in this case, what we get? We get f dash of x less than 0, or we get f dash of x less than equals to 0. This one is for decreasing. Is it clear? So this one is the condition here. Upper part increasing, lower part decreasing. So now in this case, you see, we have to find out the interval, is not it? So when we have to find out the interval, so that means if you see here from 3/4, this point is what? 3/4, is not it? From 3/4 to up to infinity, that means plus infinity. This part is what? Increasing, or we need strictly increasing. If the question is given strictly increasing, that means this 3/4 is not included, since infinity always open interval, is not it? So if strictly increasing, according to our question here mentioned, if in question mentioned strictly increasing, that means this 3/4 is not included. Is it clear? And if increasing mentioned, then this 3/4 value is included here. Is it clear? So in this case, easily we can write down the interval here now. So first interval, what you have to write down? So I write in short, strictly increasing. So strictly increasing interval, what you have to write? From where to where? 3/4 to up to infinity. So that's why we have to write here 3/4 up to infinity plus infinity, or simply you can write infinity. 3/4 to up to infinity, and in this case the interval is what? Open, not included, because strictly increasing mentioned, because it is mentioned strictly increasing. Is it clear? Strictly increasing, so that's why from where to where? 3/4 to up to infinity. 3/4 is open interval. Is it clear? And next, second one is mentioned here, strictly decreasing. So if you see the strictly decreasing interval here, from where to where? Minus infinity to 3/4. So that's why in this case we have to write minus infinity to 3/4, and this one is again open interval, because it is mentioned strictly decreasing. If it is not mentioned strictly, then we have to write this 3/4 is included, and here 3/4 is included here. Is it clear? So in this way we can find out the interval. I think all of you understood this one. Is it clear? The next question is here, find the interval in which the function f given by fx equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing and strictly decreasing. So again same question here, again we have to find out the interval here. The function is given and the question is given like in this way. If you see the question here, and the question is given what? The function is fx equal to 2x cube minus 3x square minus 36x plus 7, is not it? And in this question what you have to find out? We have to find out the interval in strictly increasing and strictly decreasing. Again strictly increasing and decreasing here mentioned, so we have to find out the interval here. The process is same, whatever we have done for question number 4, the same process we have to apply here. Now let's see how can we do this one. So in this case what you have to do now here, first of all, question number this one is 5. So first of all we have to write given. So now if you write given function fx equal to, so fx equal to how much given here? 2x cube minus 3x square. So we have to write here 2x cube minus 3x square, then here written minus 36x plus 7. So minus 36x plus 7. Is it correct? 2x cube minus 3x square minus 36x plus 7, isn't it? So this one is the function here given. So now here what you have to do here, first of all, the first step, all of you know what you have to do. We have to differentiate this one. So f dash of x. So if we differentiate this one, now in this case you see here 2 constant term x cube, that means 3x square, 3 to the 6, that means ultimately we get here 6x square. Is it clear? Minus, in this case what we get? 3 constant term, ddx of x square means twice x, 3 to the 6, that means we have to write here 6x. Is it clear? And next one is minus, here we have to write 36, ddx of x1 and ddx of 7 constant term, that means 0. Is it clear? So now here after that f dash of x, so f dash of x equal to, we have to write 0, and if we put f dash of x value here, that means this one is 6x square minus of 6x minus of 36 equals to 0. So now here first of all, if you see 6 is common here, isn't it? So if we take 6 common, then what we get here? X square minus x minus 6 equals to 0. If you see here, if we take 6 common, then here x square minus x minus 6 remain here, isn't it? So now here From here we get the quadratic equation is x square minus x minus 6 equals to 0. Because 6 is not equal to 0. Because 6 is not equal to 0, because their multiplication is equal to 0, that means 6 is not equal to 0. 6 is a real number, positive value. So that means only the possibility is what? X square minus 6x minus 6 equal to 0. So we can write here x square minus 6x minus 6 equals to 0. Is it clear? Okay, now what you have to do, we have to find out the value of x from here. So what you have to do, by middle term splitting method, easily we can find out the value of x from here. So we have to write here x square minus, this one we have to write thrice x plus of twice x minus of 6 equals to 0. 3 to the 6, that means 6 here we get. So easily we can factorize the result here. So if we factorize this result, then in the first two, what you have to write, x is common, so that's why we have to write x minus of 3. And in the second case, plus 2 is common, so that's why what you have to write, x minus 3 we have to write equal to 0. Is it clear? So now here x common, x minus 3, 2 common, x minus 3. So from here what we write? So from here we can write here x minus 3 into, we have to write this one is x plus 2 equals to 0. Is it clear? So if you take common, then we get this result. And from here we get the value of x is how much? X equal to 3 and x equal to minus 2. So that's why if we write this one is, so therefore we get two values from here, and these two values are what? X equal to 3 and x equal to minus 2. So that's why we write here, therefore x equal to 3 and minus of 2. Is it clear? So these two values are we get, these two x values are we get. Now here easily we can draw the graph here. So if you draw the number line, if you see the number line here now, minus infinity, this one is plus infinity. So algebraic expression, so easily we can apply here the wavy curve method. So first of all we have to plot the point, and the point we have to plot in such a way that according to our number line. So which one we have to plot first, minus 2 or 3? So obviously minus 2 we have to plot first, so that means this one is minus 2 and then we get here 3. Is it clear? So according to our number line, minus 2, then 3 we get. So now from the right hand side above part, we have to draw the number line here, or the graph we have to draw, and this graph moves in this way. First passing through 3, then another point is here, which one is 2. So that's why this one is again passing through 2, and any more point? No, there is no point. So that's why graph we get like in this way. Is it clear? You see here what we get. So first of all, from the above right hand side we have to draw the graph, and when we increase the or move the graph from the right hand side, this moves like in this way, passing through 3. Another critical point is there, so we have to move this one, and then there is no critical point, so that's why we have to draw the line like in this way. So in this case, if you see, this portion is what? The above portion always increasing, isn't it? So these two portions are increasing here, and only one portion is decreasing here, and this portion is decreasing. Is it clear? So two portions are increasing, this portion and this portion, and another one is decreasing. So according to our question, in this case what we have to do? Strictly increasing and strictly decreasing. The question is mentioned here, so we have to find out the interval in strictly increasing and strictly decreasing. So now in case of strictly increasing, if you see here, strictly increasing from where to where? One part is from minus infinity to minus 2, and the another part is from where? 3 to infinity. You see carefully, minus infinity to minus 2. So that's why first of all we have to write minus infinity to minus 2 open interval, and another one is from 3 to infinity. So that's why we have to write 3 to infinity, and this one is union. Is it clear? The union of these two. So next one is here now, after strictly increasing, next one is strictly decreasing. So for strictly decreasing, which portion we have to take? Minus 2 to 3. That means only this portion. So that's why open interval minus 2 to 3. So now in this case, if you see here, open interval, why we write open interval? Because it is mentioned strictly decreasing. So if it is mentioned only decreasing, then close interval minus 2 to 3 we have to write. Similarly here, close interval we have to write minus 2 and 3. Is it clear? So in this way easily we can find out the interval here. I think all of you understood this one. Is it clear? After completing the question number 5, now the next question is you see here the question number 6, and the question is given like in this way. If you see here, find the interval in which the following functions are strictly increasing or strictly decreasing. So each and every time here the questions are mentioned strictly increasing and strictly decreasing. Sometimes it is mentioned increasing, decreasing also. So in some books it is mentioned increasing or decreasing, or in some book it is mentioned strictly increasing or strictly decreasing. Don't confuse. So in question number 6, there are lots of questions are there. Under this, the first question is here. First question is what? X square plus twice x minus 5. So here very simple question. So easily we can solve this one with the help of wavy curve method, is not it? So first of all we have to consider the function. The function is here given fx equal to x square plus or minus plus twice x minus 5. So this one we get here twice x minus 5. Is it clear? So therefore f dash of x equals to what you have to write? Obviously we have to write this one is twice x plus 2. I think all of you understood this one. Differentiating this one with respect to x, ddx of x means twice x, and ddx of twice x 2 constant term, ddx of x means 1. So that's why we get here twice x plus 2. Now what you have to do? Now we have to find out the x value from here. So f dash of x equal to, we have to write 0, and from here f dash of x means we have to write twice x plus 2 equals to 0, or this implies x equal to what we get here? Minus 1. So the value of x is we get here minus 1. Is it clear? So after getting this x value here, if you see this one is the x value, after getting the value of x here, now what you have to do? If we plot this one on the number line, so that means this one we have to write minus infinity, this one we have to write plus infinity, and the value is what here? Only one value we get, which one is x equal to minus 1, and then we have to put minus 1 here. So that means this one is the minus 1 here if we plot. Is it clear? So if x equal to minus 1 here, now easily we can draw the wavy curve from the right hand side. So that means if we increase the line in this way, then the graph we get like in this way, you see. Is it clear? So now here this portion is what? This portion is increasing, and this portion is what? This portion is known as decreasing. Is that it? So increasing and decreasing part. So that's a strictly increasing answer according to our question. So strictly increasing. So strictly increasing, if we write from where to where? Minus 1 to infinity. So that's why we have to write here minus 1 for infinity. Is it clear? And strictly decreasing. For strictly decreasing, if you see the interval is from where to where? Minus infinity to minus 1. So that's why we have to write minus infinity to minus of 1. Is it clear? Open interval. So in this way easily we can write down the interval here. Is it clear? I think all of you understood this one. So in this way easily we can solve each and every question if algebraic expression given. Remember, if algebraic expression given, so only in case of algebraic expression we can use this wavy curve method. This curve is known as wavy curve. Is it clear? Wavy curve method. So I hope all of you understood these three questions here. Three questions here. So in our next class we have to continue this exercise, and question number 6, first question is here done. So from the second question we have to continue this. Is it clear? Okay, thank you.